Welcome students. Today we are going to discuss about the electrolysis. In this section we will discuss the theoretical aspects of the electrolysis. Electrolysis is a phenomena of decomposition of an electrolyte by passing electricity through its either aqueous solution or molten state. Electrolysis is carried out in a cell which is called as electrolytic cell. This is shown in this diagram. In electrolytic cell, we take electrolyte in either molten state or in aqueous solution state. It is shown by orange colored dots. In the electrolyte, we dip two electrodes. One electrode is called as anode and another is called as cathode. Anode is shown by red color and cathode is shown by green color. Anode is positively charged and cathode is negatively charged. When we pass electricity through the electrolyte which is in its molten state or in its aqueous solution state, then at the anode there is oxidation and at the cathode there is reduction. Means anode is that electrode at which oxidation takes place and cathode is that electrode at which reduction takes place. As a result, your electrolyte will be decomposed. Its anion, that is negatively charged, will be attracted by the anode. It will start to move towards the anode, and when it touches to the metal rod of anode, then it get oxidized. Similarly, the cation of the electrolyte, that is positively charged, will be attracted by the negative cathode, so it starts to move towards the cathode, and when it touches to the metal rod of cathode, it get reduced. As a result, the electrolyte is decomposed. We will take an example of the electrolysis. Suppose we electrolyze NaCl molten using the electricity. NaCl is an ionic compound, so it gives Na plus ions and Cl minus ions. Na plus ion is a cation, so it will move towards the cathode. When it touches to the metal rod of cathode, then it get reduced by taking electron from the metal rod of cathode and change to sodium metal. So you'll get here sodium metal as a product. At anode, Cl minus ion, that is anion, due to its negative charge, it will move towards the positive anode. And when it touches to the metal rod of anode, it get oxidized. Means it will lose its electron and form Cl2. If you join these two equations, means if you add these two equations, you will get the net reactions occurring in this electrolytic cell. While adding the two equations, the electrons gained at cathode and electron lost at the anode must be equalized, and for that the equation occurring at cathode will be multiplied by 2, so that 2 electron at the side of left hand side and 2 electrons in the right hand side will be cancelled, and now add the two equation, you will get twice Na plus twice Cl minus equals to twice Na plus Cl2. So this is the net cell reaction occurring in this electrolytic cell. Sodium is deposited at the cathode and chlorine gas is liberated at the anode. So the product of this electrolysis are sodium metal deposited at the cathode and chlorine gas liberated at the anode. This reaction is taking place when you pass electricity, means it use electricity. That kind of reaction which takes place with the help of external agencies are non-spontaneous processes. So an electrolytic reaction or electrolysis is a non-spontaneous process that cannot occur on its own. It has no natural urge to occur. It can take place with the help of electricity. Okay? The Gibbs free energy change for such type of reaction will be positive. Now we will discuss criteria for product formation during electrolysis. Suppose an electrolyte is electrolyzed in its aqueous solution state, then water will be as a competitor at the anode as well as cathode, because water is a substance that can be oxidized and as well it can be reduced. So at the anode it is competitor for oxidation, but at the cathode it is competitor for reduction. So if two reactions are in competition at the anode, then the reaction for which reduction potential value is less will be taken place with first preference. This is the first criteria. At the cathode, if two reactions are in competition, then that reaction will be taken place with first preference for which the reduction potential value is high. Once again, if there are two reactions are in competition, then that reaction will be taken place with first preference at the anode for which the reduction potential value is less. There may be two or more reaction, but that reaction will occur with first preference for which the reduction potential value is less. And at the cathode, if there are two or more reaction in competition, then that reaction will occur with first preference for which the reduction potential value is highest. If any reaction that is with first preference should occur at any electrode is kinetically very slow and require high voltage for its occurrence, then the second reaction the preference will be taken place. This is the third criteria. So in the case of over voltage, what is over voltage? Over voltage is the extra potential which must be applied to carry a particular reaction. So a reaction, if it is in first preference to be taken place at an electrode, if kinetically very slow and require extra potential, means over voltage to occur, then it will not be taken place. In place of that, second reaction in the preference will occur at that electrode. So in case of over voltage, reaction with second preference will occur. First preference reaction cannot take place as it is very slow at the applied potential. It requires high potential to occur with appropriate rate. So it will not be taken place. So reaction with second preference will be taken place if there is phenomena of over voltage. Now take an example of the electrolysis of NaCl aqueous solution. When we electrolyze NaCl aqueous solution, first of all NaCl will dissociate to give Na plus and Cl minus ion. At the anode, Cl minus ion will go where it can be oxidized into Cl2 by losing 2 electron. Simultaneously, water may also be oxidized into 2H plus half O2 plus 2 electron. The E naught reduction potential value for the first reaction is 1.36 volt, whereas for the second reaction it is E naught 1.23 volt. So at the anode, that reaction should be taken place with first preference, for which the E naught value is less. So according to this point, water should be oxidized with first preference and Cl minus ion should not be oxidized. But here the second reaction require extra potential. It is extremely slow reaction, and it require extra potential, means over voltage is required to carry out this reaction of oxidation of water. And therefore the reaction with second preference, for which E naught value is not less but it is high, that will be here taken place with the first preference. So this will be taken place and this will not be taken place, and the reason is here why, because the second reaction requires over voltage to occur. That's why the second reaction, which must be with the first preference, but here it cannot be taken place. So the second reaction, second preference reaction will be taken place. So here the product of electrolysis is Cl2 at the anode. Now at the cathode. At cathode, Na plus ion will go where they get reduced to Na. And water may also be reduced here to give half H2 and OH minus ion. E naught value for the first reaction is minus 2.71 volt, and for the second reaction it is minus 0.83 volt. If you compare these two values, you may find here that the second reaction has high E naught value, and you know that at cathode that reaction takes place with first preference, for which E naught value is high. So definitely the second reaction will be taken place with first preference, not the first one. So the product of the electrolysis at the cathode will be H2 and OH minus N. So if you conclude here, then at the anode we will get here chlorine as the product, and that is not due to its less E naught value, but it is due to the over voltage requirement for the reaction that should be taken place with the first preference. And at the cathode we will get here hydrogen and OH minus ion as the product because of the high E naught value as compared to the reduction of Na plus ion. So we can write equation like this: NaCl when electrolyzed in presence of water, then its sodium ion will not be reduced at the cathode, it will remain as such, and water get reduced, so it form H2 and OH minus ion. So at cathode you are getting product H2 and OH minus ion along with Na plus, which are not reduced here, and at the anode we get chlorine gas as the product. Now we will discuss the electrolysis of copper sulfate aqueous solution using platinum electrode. Platinum electrode means inert electrode because they are not taking part in the reaction. At the anode, the anion sulfate will go where it can be converted into S2O8 minus and it will be oxidized to lose 2 electrons. The second reaction which may occur at the anode is oxidation of water. It gives oxygen 2H plus and lose 2 electron. If you compare E naught value of these two reactions, for the first reaction means for the oxidation of sulfate, E naught value is 1.96 volt, and for the oxidation of water, E naught value is 1.23 volt. At anode, that reaction take place with first preference for which E naught value is less. So oxidation of water must be taken place with first preference, and this reaction oxidation of sulfate that must not be taken place. It means the product formed at the anode should be oxygen and H plus ion. Now at the cathode, at cathode copper plus 2 ion will go where they can be reduced in copper, and water may also be reduced into H2 and OH minus ion. If you compare their E naught values, E naught for the copper redox couple is plus 0.34 volt, and for the water reduction it is minus 0.83 volt. The first reaction has more E naught value, and you know that at cathode that reaction take place with first preference for which E naught value is high. So the first reaction must occur with the preference and the second reaction should not be taken place. Means at the cathode copper must be deposited at the electrode. So if you conclude copper sulfate aqueous solution when electrolyzed using platinum electrode, then at the cathode we'll get copper as a product because copper ion are reduced with first preference, and at the anode sulfate ions are not reduced. In place of water, in place of sulfate ion, water is oxidized to give oxygen and H plus ion as a product. So this is the overall equation. Now let us discuss the copper sulfate aqueous solution electrolysis using the copper electrode. Previously we have discussed electrolysis of copper sulfate using the platinum electrode. Platinum electrode are inert electrode, they don't take part in the reaction. But copper electrode will be here reactive electrodes. They may interrupt the reaction, they may take part in the reaction. So at the anode, now there are three reactions in the competition. One is sulfate may be oxidized into S2O8 minus. Second, water may be oxidized into O2 and H plus ion. And the third, copper electrode may also be oxidized to give Cu2 plus and 2 electron. If you compare the E naught value, then you find that E naught value of the last reaction is minimum, that is 0.34 volt, and at anode that reaction must be taken place with preference for which the E naught value is least. So this reaction will occur with first preference and remaining two reaction cannot take place. So you will get the product at anode as copper 2 plus. Okay. Previously when we have used platinum electrode, then the second reaction was with first preference, that is oxidation of water and O2 and H plus, and we have got as product. But when we have changed the electrode copper electrode, then now copper electrode will be oxidized to give Cu2 plus ion. So there is change in the product when you change the electrode from platinum to copper electrode. Now at the cathode. At cathode there will be no change. Here there are two reactions in the competition. Copper 2 plus ion may be reduced to copper and water may be reduced to H2 and OH minus ion. If you compare their E naught value, then this value is high. At cathode that reaction takes place with first preference for which E naught value is high. So the first reaction will be taken place with the first preference, second will not occur. Means you will get copper deposited at the cathode. So at the anode copper will be oxidized to give Cu2 plus, and at the cathode Cu2 plus will be reduced again to copper. So these are the product of electrolysis when you electrolyze copper sulfate aqueous solution using copper electrode. Now I have made here a general order of preference at anode for the oxidation. Cl minus ion, Br minus ion, and I minus ion, they have preference over water. Cl minus ion has preference over water due to over voltage required for the oxidation of water. So if water and Cl minus ion both are present, then water cannot be oxidized even though its E naught value is less. And Cl minus ion, which is the second preference, will be having high preference than water. Br minus ion and I minus ion, they have preference over water due to their less E naught value. Their oxidations have less E naught red value. That's why they have more preference over water. Now F minus, NO3 minus, and SO4 2 minus, and these are the ions oxidation for which have high E naught red value than the water oxidation. So these have less preference than the water. यानी अगर सॉल्यूशन में F माइनस नाइट्रेट या सल्फेट प्रेजेंट है और वाटर भी प्रेजेंट है तो वाटर ऑक्सीडाइज होगा, ये तीन आयन नहीं ऑक्सीडाइज होंगे. जबकि Cl माइनस, Br माइनस और I माइनस प्रेजेंट हैं तो वाटर ऑक्सीडाइज नहीं होगा, ये ऑक्सीडाइज होंगे. Now, the order of preference at the cathode. I made here a list of cations along with water that is shown in middle. The preference towards reduction at the cathode increases. It is because of the reduction potential value for their redox couple increases. So as you move left to right in this series, which I have shown here, the reduction potential value for the redox couple of these ions will be increased, so the preference of these ions to be reduced at the cathode will also be increased. So this is all about the theoretical aspects of the electrolysis.